Hello everybody, I'm Teacher Yusen and today we are back again with our challenging question series. And the question that we'll be dealing with today is about our irregular area calculation. So without further ado, let's jump straight into our question. This question here says that in quadrilateral ABCD, we have AB equals to BC equals to 9 centimeters. AD minus DC equals to 8 centimeters. AB is perpendicular to BC and AD is perpendicular to DC. So now our question tells us to find the area of this entire quadrilateral ABCD. So the first thing that we should be doing after we read through the question is to, of course, label down all of the information. As we all know, AB and BC are both 9 centimeters each. And now AD minus DC is equals to 8 centimeters. But from this, are we able to get anything out of it? For now, no. So we continue on with AB is perpendicular to BC and AD is perpendicular to, of course, DC. Now we are asked to find the area of this quadrilateral. But there's a small problem with this. Do we know how to find the area of such a shape? I think most of us would have never learned about finding the area of such a shape before. So now we think, how else can I do the question then? Because we have never learned about this. But I think we have learned about how exactly to find the area of other types of figures. What are some easy figures that we know how to find its area? Of course, triangles, squares, rectangles, and so on. So we'll try to make this figure into something that we are more familiar with. What can I make this quadrilateral into? And from it we can see that just by adding one singular line, I should be able to split up this figure into two parts, or essentially two triangles. How can I split the figure then? I can either split from A to C or from B to D. But now, which way do we want to split it out? Some of you might be thinking, since the question already gives me two 90-degree angles, of course, we'll want to try to make use of them and form our right angle triangles, which gives us the line AC over here. So now with the line AC, what can we find from the figure? Now, of course, we can find the area of this triangle. How do I find the area of this triangle? Half times base times height, which gives us, of course, 9 times 9 divided by 2, which is equals to 40.5. Oh, we are almost done with the question. We have found this area to be 40.5. Now there's just one small thing for us to do, and that is to find ADC. How do I find this part of it then? We think, if I want to find the area of triangle ADC, we need half times base times height again, and that is AD and DC. But there's another problem now. We do not know any of the values of it. We just know that AD and DC are related by a difference of 8 centimeters. Now we think again. If that is the case, then what do we do now? If I really need one of those sides to be able to find my area of the triangle, what else can we do? I think we are familiar with this also. If I really need a value but I do not have it, I can first represent it using a variable. And what variable can I put? Of course, I can put one of them as x. But which one exactly as x? Either one of them is fine, but to make things easier for us, we make the shorter one, which is CD, as x. And then what will be the length of AD now? The length of AD will now be, x plus 8. So with that being said, now we have the values of CD and AD. And we think we should be able to find the area of this triangle ADC now. But there remains another problem, which is that we do not know what is the area of X. So now we think, we have a right angle triangle and an unknown X that we need to find. How can I find for this value of X then? So here, let me introduce to all of you something else. When we're dealing with right angle triangles, we should know one thing, and that is also known as the Pythagoras theorem. What exactly is a Pythagoras theorem? For those of you that know, great job. But for those of you who have never heard of it before, here it is. If I have a right angle triangle with the sides A, B, and C is the longest side of the triangle. Okay, longest side of the right angle triangle. Now, we'll have this equation that we can write, which is a squared times a squared plus b squared, giving us c squared. That is the idea of our Pythagoras theorem. So how is it helpful for us in this case then? If we notice, we have split this figure into two right angled triangles. And that means, since I have both of the sides, which can be known as A and B, I should be able to find AC squared. So with that, let's jump straight in back to our question. Now, I know that AC squared is equals to AB squared plus BC squared. Now, substituting the values in, I know that it is equals to 162. So this line AC is equals to 162. Now, what is next? We see that we have another right angle triangle, which is CD and AD, of course. So with that, what can I write now? Again, I can write down that AC squared is equals to AD squared plus DC squared. And this should give us x squared plus x plus 8 squared. Now some of you might be wondering, what exactly is this? 8 plus x squared, how do I solve it? So do not be worried. Well, let us take a quick look at how we can deal with this type of values. Squares. Of course, they must be related to the shape squares, right? So we can imagine we have a large square with each of its sides being x plus 8 centimeters. And now, by adding a line over here, I can split it into x and 8 respectively. Similarly, doing it to the other side, which is the height of the square, I can do the exact same thing, splitting up into x and 8. Now, am I able to find each of those parts of the area? Of course we can. And we know that this part, what is it? X squared. These two parts should just be 8x, and of course the last remaining one, 64. So now, do I know what is the value of x plus 8 squared? We know it, and it is x squared plus 8x plus 8x plus 64. And with that, I can write it down here. Once I write down here, I can solve and simplify for it to get 2x squared plus 16x plus 64. No, just now we mentioned that since both of them are AC squared, they're the same line. So what can we do? We can equate them together and we can try to solve for our value. So now when we are dealing with this type of equation, what do we usually do? What we usually do is we shift all of the constants from one side and we put it all the way to the other side. And that should give us 2x squared plus 16x is equals to 98. Now, for this part, what do we notice on both sides of this equation? They both have a 2. So what do we do now? To simplify it, we take out the 2 and we remove it from both sides to get x squared plus 8x is equals to 49. But again, we are faced with another problem now. How do I solve for this part then? Do I know what is the value of x? I think none of us at primary 5 have learned about this before, so we cannot solve it yet. Then how do we solve this question then? Now, we think, what was our question asking us for? We wanted the area of this quadrilateral. So essentially, what else do I need from the figure? I just need the area of this triangle ADC over here. What is the formula for a triangle's area? It is just going to be half times base times height, which is essentially x times x plus 8 times a half of course. And with this already being there, let's try to see what we can represent the area as. This area is as such. And if we look carefully at it, what do we notice? Oh, we notice that this part on the right is essentially just our 49 out there. So we can substitute it back in and put it over here. And now, what is the area of ADC? It is just going to be 24.5. So now I know that this part is 24.5. Can I find the area of the entire figure now? Of course we can. So we just need to add both of them up and I get my answer as 65. So we have successfully solved the question and found the area to be 65 cm squared. So now, what did we learn from this question today? It's very simple. If I first see an irregular shape, now what do we do with it? We cut it up into figures that we are familiar with or regular shapes. Now, aside from that, what else? We also learn about our Pythagoras theorem, where I know for right angled triangle, the two sides squared added up together is equal to the longest side squared. And that is all that we have for our challenging question today. That was from our exploration class selection test. So if you are interested in knowing more about our exploration class, do stay tuned for my next upcoming video on it. With that being said, here we still have a short practice question that is very similar to what we have just did. So don't forget, if you have tried out the question, just remember to put the answer in the comment section below and I'll try to respond to that quickly. If you have any other queries, feel free to just join our WhatsApp group over here and our teachers at Kangaroo Study will be very glad to help all of you solve your questions. With that being said, don't forget to hit the like button and subscribe to our channel below. Thank you and bye-bye.